Hey, Brian from RVwithtito.com, and today I wanted to share with you a project that I'm actively working on right now to remodel my solar charging compartment in the RV. And I wanted to share this with you because it raises a couple of issues that I wanted to talk about. I'm going to be replacing my existing Morningstar Mppt solar charge controller with multiple Victron Mppt solar charge controllers, and that's going to be the first thing I want to discuss. Is first of all, why am I doing that? What do I hope to gain by doing that? And also, how am I going to actually hook it up in order to be able to charge my single battery bank with multiple Mppt solar charge controllers? So there are some things that need to be done right in order for this to work properly. So I'm also going to be just replacing all the cabling and adding some new circuit breakers, and a lot of other gear is going to go in here, which leads me to my second topic, which is, how am I going to get all of this stuff in this small compartment here and not create this giant mess? Well, turns out I've been thinking about this for a while, and I've actually come up with a solution that I think is going to work really well, and I'm excited to show it to you. Today's video is brought to you by 3-in-1 Lock Dry Lube. Using this dry lube on all of your door locks, compartment locks, even padlocks will keep those mechanisms lubricated and protected from corrosion. Once sprayed on, it dries quickly and won't attract dirt or leave behind any residue. I've always used some sort of spray lube on the locks in my vehicles, around the house, and the RV for years. Over a year ago, I switched over to this stuff, and I don't know what it is about this formula, but it really does work better than anything else that I've tried. And I recommend you keep a can or two around the house and in the RV. And you can find it at Walmart in the hardware section, or you can always find it on Amazon. And if you'd like to learn more about this and the other 3-in-1 products, be sure to go visit them online at 3in1.com. That's the number 3in1.com. Now let's get on with our project. So why have multiple Mppt solar charge controllers in the first place? Well, the primary reason for doing that is if you have multiple, so more than one solar array trying to charge a single battery bank. And you might be thinking, why would I have that? Well, let's look at my my situation here as an example of maybe what not to do. So it's typically frowned upon to mix and match different types of solar panels in a single array, because you're probably not going to get the most optimal output out of that system. Usually the lowest, the panel type with the lowest specs, is you're always going to drag down the output of the system to that level. So it's not typically a good idea. But in my situation, I started out with these unisolar panels, these long, skinny, thin film panels. You can see there's 3 of them. They're rated differently, much differently than the newer panels that I have, which is those HQST 100 watt panels. 3 of those for 300 watts total. And the unisolar ones total about 250 watts. But they put out different voltage. One of them puts out 44 volts and the other's like 28. And the other 100 watts are completely different. So I've tried over the years to kind of configure them and set them up in a way so that mix and matching the parallel versus serial to try to get an optimal output of them out of them. But I don't think I've really been able to achieve their maximum potential. So what I've done now is to actually separate those 2 different panel types into separate arrays. Unisolar panels, those long skinny ones, are on one separate array, and the 3 HQST panels are on another array. So each one of those arrays now has its own dedicated, or will have its own dedicated Mppt solar charge controller. I actually have a third one, which is for my portable solar array. I've got those solar awnings, or just a portable setup that I'll throw out, and I have a plug that I can plug those into just outside the solar charging compartment. For that, I have another small Victron little solar charge controller that I use to take that input from those panels and combine that with the rest of the system. So that's the why. But this new setup is actually going to have some benefit for me, because now I'll have two different panel types on separate arrays, which means that each one is not going to affect the other one. And if there's any performance degradation or shading or any problem with a panel on one of those separate arrays, the separate systems, it's going to have zero impact on the other one. And the same is true if one of these panels fails, for example, and it's not going to bring down the whole system. It's just going to affect that individual array, and I can just take that offline and still be able to get solar from the rest of the system. So each one of these charge controllers is going to be tied to each set of panels. So one specific array is going to be dedicated to one of these charge controllers. So I got the two larger ones that are going to feed the two larger sets of solar panels, and then this small one is going to go for and take that power from the portable solar setup, my external little portable setup. So there's a couple things that have to happen in order for this to work properly, and I want to walk you through that. So the first thing is that we're going to have to set all of these up so that they are all charging the battery bank in parallel. So we're going to have to make sure that the outputs of these are all connected in parallel. And I also want to be able to keep the cable lengths the same. So in order for this parallel setup to work the best, it would be best that they're all kind of the same distance from the battery. So when I run my cables, I want to make sure that the cable lengths are about the same. They're physically going to be located in the same area. So the second thing that we need to do properly here is to make sure that all three of these charge controllers are all programmed the same, so that they basically share the same charging profile for my battery. Because the way that these multi-stage chargers work is that they charge up to a certain voltage, and then they switch to a different phase of the charging cycle. And we want that to occur at the same time for all three of these charge controllers. So that's actually the primary reason why I decided to just go with all Victron charge controllers, because they're all charging the same and they're all fully programmable, so I could set them all to be identical in terms of the voltage in which the voltage that they switch at to go to the next phase between bulk mode and absorption mode. And yeah, so let me set this all up and kind of lay it out to show you how I'm going to connect all the components, and we'll try to get an overhead shot here so you can see. Now coming into the charge controller, we're gonna the main arrays are gonna go through these circuit breakers. So each one's gonna have a circuit breaker, which is also gonna double as a cutoff switch. So there's gonna be one for each of these on the inputs. Now the smaller controller doesn't really need one. I already have a switch that's in line with the input for that plug, and this controller also has a small fuse in it too, so won't need the circuit breaker for that. So I'll just leave those there just so you have an idea. So to achieve this parallel setup, what I'm going to do is take all the outputs through these two bus bars. So I have a negative bus bar and a positive bus bar. So to run all those, I'm essentially, let's say this is going to be the negative output from this one, and this will be the negative output from this one, and the negative output from that one. And the same thing on the positive side, the outputs from the positive will just be the same. I'll run the output to the positive bus bar from each one of these as well. Just like that. Now the outputs from the bus bar, there's going to be another thicker cable that's going to go to the battery, but it's going to go through a couple of different components. So on the positive side, I want another circuit breaker. So this is a heavier duty circuit breaker that I can take much thicker cable, and it's an 80 amp circuit breaker. Primarily this is going to be for to be used as a cutoff switch, so I can use it to shut off the solar input to the battery if I need to, and it's also going to provide some overcurrent protection. So I'm just going to take a thick number 2 AWG cable off of the positive, and then run that to the input of this circuit breaker, and then the output of this circuit breaker is going to go to my battery on the positive side. And on the negative side, I have a battery monitoring system, so I am going to take a output into a shunt that's going to be wired in here. Not this particular shunt, just for a illustration. And the output of that shunt is also going to go to the negative terminal of the battery bank. So that's the basic setup for this parallel configuration. And the final thing here is to wire in a ground. So each of these larger controllers have a ground here. So I'm gonna take that here and wire it to this lug here, and that's going to go to my chassis ground on the RV. So that's the basic setup. Now I picked up all this stuff on Amazon, so if you're interested in a parts list, be sure to check the description or the little video pop up here. So the next step in this project is to get all of this stuff neatly installed and organized in that small compartment in the RV. So I took those measurements from the RV and I came into the shop here, and I just made a replica of that compartment out of cardboard so that I could just kind of look at it and experiment with some different options here. And you know, I made measurements to where the vent holes were, where the cable was coming in. I had to get a little creative and came up with some ideas, and I scribbled up this little drawing here, and I decided to go with a rack system. So I engineered this basic little rack system out of aluminum, and here's what I came up with. So this is I painted it black, but I needed something that I could store everything in here, and it was organized and easy to get in here. So I went through a few iterations of this. You know, once it's configured, I can set this actually in here and actually install it like that, you know, without having to take everything apart again. Part of my goals here for the for this rack is to be able to first of all, I wanted to make sure that, you know, I could mount other things back here that I could get behind here. So I wanted these rails to be to first of all take the charge controllers and mount them at an angle, because I want they got a heat sink on the bottom, and I wanted the, you know, to be angled a little bit so that there's a nice little place for the heat to escape up instead of getting trapped in the bottom. But I also wanted to be able to get behind here without uninstalling anything. So this needed to pivot. So I using pop rivets as these little hinges, and I'm able to actually lift this up and actually get underneath this rack system like that. So I could lift it up when I need to get underneath, and it's pretty accessible. Works pretty good. I know a lot of you guys might be thinking, you know, what about heat? It's kind of a small space, and this compartment actually does stay fairly cool. When I built it, I installed a couple of screen vent holes on either side, so there's always a nice bit of airflow going through this compartment. But So I'm just going to monitor it. I'm not going to worry about putting a fan and all that in here right now. I'll monitor the temperature. But I did go ahead and pick up a little temperature control switch that I can adjust, and it'll switch on when it reaches a certain temperature, like maybe 80 degrees or something. And I've already tested it with this little fan. I'm just kind of pulled out of a piece of equipment, computer or something. So I could just mount that here to one of these holes and then put this controller in there when I need to, but I'm not going to do that initially. So finally I'm going to wire it all up, and went ahead and picked up some welding cable. This is great stuff that I got off of Amazon. It's really pliable, easy to work with. So this is like number 2 cable. Look how flexible that is. And it comes with lugs and heat shrink already. So I have some number 2 cable, and I also have some number 6 cable. So most of the internal cabling is going to be with number 6 AWG, and then outputs to the battery bank are going to be number 2. But yeah, I'm going to replace all my cabling. This stuff is so much easier to work with than this really stiff stuff that I got from Home Depot that I'm using now. Okay, I've got it all wired up here as much as I can in the shop with all the circuit breakers and everything on this end of it. Now the rest of it's going to have to occur down at the RV. I'm going to get the rest wired up down there. So everything is finally hooked up, powered up, and I'm pretty excited to see this finally all come together. Check it out. So the last step of this whole install is to get all of the controllers connected and set up through this Victron mobile app. Now, since they're all Bluetooth, it's just a matter of connecting them and making them visible to the Bluetooth app on my Android phone. Now, there's a version for iOS as well. But once they're connected, you can rename them, and you can, customize all of the charging settings that you need to for your specific battery bank. Now what I did is I went ahead and just kind of created 3 different arrays on mine for each controller, and I named them accordingly. So you can rename each controller. The other thing is to go through the settings for your charge profile and your battery charging settings and set them up so that they're all identical. Now I went ahead and just set them for my particular AGM batteries, and I just suggest that you go contact your battery manufacturer and make sure you have the right settings for your specific type of battery. And you want to be able to set your bulk charge level, your absorption level, and finally your float level. And once you have that all set up, the last thing that I did was to go through the the Victron little networking tool in the settings and create a little network that all of these guys can join, so that they're all now connected to each other and aware of each other. So that'll help synchronize them while they're charging the battery. Now I'm going to continue to play around with this. So far I think it's working properly, but if I learn something new about this whole setup, I will certainly add to this discussion in the comments. So, interesting little tidbit here is that I've just realized that now that I can see each set of panels independently, is that the unisolar panels that I have are actually outperforming my HQST panels right now. And that's interesting because the unisolars they're a thin film panel, and the HQSTs are, monocrystalline, newer panels. But anyway, a little tidbit. I hope you guys are able to get something out of this project that I shared today. Maybe get a new idea or a new approach on how to do some of these things. And if you have any questions, of course, leave them in the comments. And I'd also love to hear if you guys have had similar challenges like I did with this small compartment and hooking up multiple controllers like this, and how you overcame those challenges. I'd love to hear about it. I'm sure everybody else would as well. But this has been a fun project for me to work on, and if you guys liked it, please give it a thumbs up. And if you want to become part of this community, it doesn't cost anything to join. Just hit that subscribe button. But take care, and I will see you in the next one.